So our lesson objective, okay, for you is I will be able to prove two triangles congruent, ASA congruent, and I'm going to put or, because, you know, it's not usually they both. Whoops, let me move that down. AAS. So we just went over what it was. You know, it was already written out in your journal. And again, angle side angle congruence can be written like this. And I already explained it. We know that if you have two angles congruent and the included side, that's what's super important, included side, then you've got congruence. So that is super important. Okay, so here's the question. Can the triangles be proven congruent with the given information? If so, state the theorem. So if I were you, what I would do with this picture is, like, I would probably redraw it, okay? Because I've got a triangle here and I've got a triangle here. And I'm just going to look at them separately. I've got 1 and 4, 2 and 3. The other thing I know about this picture is that I have parallel lines. So hopefully you remember that those little triangles mean parallel. So these are actually parallel lines, which, if you recall from, I don't remember which chapter it was that we did all those parallel lines. Do you remember that that makes this a transversal? So if this is a transversal by alternate interior angles, which ones are congruent? Hopefully we have a reminder here. So you've got, here's your transversal. Okay. Is it going to be 2 and 4? Yes. 2 and 4. Because if it's like this, yes. So from that, we know that angle 2 is congruent to angle 4. Thank you. I volunteer. Now, another thing you're going to notice here, I'm just going to redraw it like this. These are also parallel. So these are parallel. Here's my transversal. Now I can say that what else by alternate interior angles is congruent? So just with what's given in the diagram, I have two angles that are congruent. Okay. Now you can all see that now. If I had highlighters, I only have a couple of colors. My colors have all died. But I would highlight it in different colors. But now I know that 1 is congruent to 3. I know that 2 is congruent to 4. And if I want to use, say, one of these theorems, I need the side in between or one of the other sides. Well, clearly, WX is congruent, WY is congruent to WY, right? That's in between, and both of those triangles have it. It is the side that's in between the two, so did I just say it again? Okay. WY is congruent to WY. If I was going to actually write it out by reflexive congruence theorem, or property, it's actually a property, and therefore, yes, it can be proven by the angle side angle congruence theorem. It's, you know, you don't have to write a lot, but you do have to, like, draw the pictures or show what this is and do that somehow on your notes. Okay, any questions? Now's the time to ask. before we go on to like any kind of a proof? Okay, great. Write a 2-column proof. We've got 2 triangles here. We're going to look at the statements. Let's read through it, mentally make a plan, and then write it out. Okay, so I am given, let's see, I'm given that AD is parallel to EC. So what I'm going to do, just because it helps me, is I'm going to extend these lines so I can see that they are parallel. You can even make them solid if you want, but that means they're parallel to me. I also know that BD is congruent to BC, so BD congruent to AB. All right, and obviously our first step is whatever is given. So I'm going to rewrite this. AD is parallel to EC, and BD congruent to BC. Okay, so now that I have that given, now the question is, what do I want to prove? So before I, see what to do next, I want to prove ABD is congruent to EBC. So a couple of things you have to remember. First of all, whenever you're given something like this, you always need to use that. You're not given something that you don't use. This is not how to confuse the student. Okay, there are some problems like that where they just throw in extra information to see how easy it is. That's not this. How are we going to use these parallel lines to figure out if these are congruent or not? Well, just like this example, you're going to somehow get that some angles are congruent, right? Hopefully you can see that. Since these are parallel, you're going to be able to use either this as a transversal, or you can use this as a transversal. So, like, which one would help you the best? That's what I would look at next. And I think, well, okay. This one would give me these 2 angles. Are those 2 angles going to help me? Or when I look at this transversal, I'm going to get this angle is congruent to this angle. And see, so since it's connected to this, that seems like it's going to be a lot more helpful. So I'm just going to highlight this. This will be my transversal, and that's just how I decide. I look at the possibilities and figure out, yeah, that one's going to be better. It's going to be better because it's connected to what's already given to me as congruent. So I think I can say that that and that is congruent by alternate interior. And then if I have an angle and a side, and we know it's under the ASA theorem as an example, I need another angle. How am I going to get the other angle that's on the other side of these? So again, we're still just talking through this. I've got this angle, I've got this side. How will I get this angle congruent to this angle? And then you think to yourself, oh, those are vertical. Those are vertical angles. So once I have my transversal, I've got my side, I can say these 2 are congruent. Then I can say these 2 are congruent. Then I can say that these triangles are congruent. And there you go, that's my proof. So that's a total of 4 steps. I always like to know how many steps I have going in. That doesn't mean you have to do it that way. It just feels better to me to know what's going on. Now that I've talked it through, now I should be able to do it. So that first thing I did was I'm going to say these 2 angles. Or I could just say these 2 angles, either way. So why don't I start with this one because I have a little more room here. So angle ABD is congruent to angle, A's here, so E is corresponding. EBC by vertical angles are congruent. Then, so now I have this. That's good. Now I can say that ADB, this angle here, angle ADB, sorry, ADB. That's why working in pencil is sometimes better. ADB is congruent to this one here, which is ECB. And again, this is why the ordering matters, because that's a different angle if I had switched that. And those are congruent because alternate interior angles are congruent. Which means now I can say that my triangles are congruent. EBC by the angle, included side angle congruence theorem. All right, so any questions right now?